Today we will understand
big omega and big theta,
which help us analyze algorithm growth.
While analyzing algorithms, we don't just care about maximum time,
which is big O.
We also care about the minimum time and the exact growth rate. This gives us a complete understanding
of performance.
Think of it like driving a car. Big O tells us the maximum speed.
Big omega tells us the minimum speed. And big theta tells exact range of speed. Big omega tells the lower bound of a function. Tells how fast a function grows at minimum.
Mathematically we say f of n is omega of g of n. If fn is greater than a or equal to a constant times gn, for large values of n.
Consider the function 8n cubed plus 5n square plus 7.
For large n, 8n cube omits the function. So fn is always greater than a or equal
to 8n cube.
Therefore fn is omega of n cube. Here in graph the blue line is in Q3.
This red curve is our function. Notice it stays above. If a function stays above another function, it is omega of that function.
Big theta represents the tight bound.
Tells us the exact growth rate of a function.
Mathematically we say f of n is theta of g of n.
If it is both greater than and less than constant multiples of gn. So it is bounded from both sides.
Consider this function, 8n cube plus 5n square plus 7. For large n, the dominant term is n cube.
So the function behaves like n cube. In this graph we are visualizing big theta notation. The blue curve represents our function.
The orange curve represents lower bound. The green curve represents upper bound. Notice that as n increases, the blue curve stays between these two curves.
This means our function grows at the same rate as n cube. Not faster, not slower in the long run. So we say, big theta gives us a tight bound,
meaning it captures the exact growth. Let's summarize. Big O gives the upper bound, worst case. Big omega gives the lower bound, best case. And big theta gives the tight bound, exact growth. For this function, the highest hour is n square. So we say it is big O of n square. Big omega of n square. Big theta of n square. Big O means at most. Big omega means at least. And big theta means exactly.
For example, think of marks. Minimum marks are 60, maximum are 80. So the marks always lie between 60 and 80. This range represents theta. The full picture means complete understanding of how a function grows. Theta is equal to both big O and big omega combined. If you know big theta, you automatically know both big O and big omega. For example, consider the function. F of n is big theta of n square.
This means two things at the same time. Here we break theta into two parts. Lower bound gives omega. Upper bound gives big O. Together they form theta.
Thank you for watching.